Hey, I'm waving. And Ted waves back. Ted, I'm looking at your ceiling and I don't know what the heck you got going on, but it's an interesting look. Is that something hanging? Yeah. Your volume is like at level 0.
It's a house plant.
Really? It looks like a. Okay, I believe you. I
It's a
just
little
don't.
like triangle setup with
Yeah.
it.
Oh, it's like a house plant in a triangular shaped pot.
Yes.
Okay, so I was thinking houseplants don't normally come in triangular, but got it. Okay.
Picked it up
Oh,
from the Back Bay Pottery.
Back Bay Pottery. Uh, do you see behind me?
Oh yeah.
Yeah.
Nice.
So
That
right about
picture
that
was
same
on
place.
Nextdoor, wasn't it?
Yeah. So
Yeah.
don't tell anyone that that's where I steal all my backgrounds from. Or do any of you know the guy who posts them?
Steve, what's his face?
Paul Irving.
Steve Powers. Oh,
Oh,
Paul
him too.
Irving. Yeah, he
Yeah.
posts a lot of them.
So anyway, yeah, if you see me in Ralph's and Los Osos, that's fine. I'll be the one waving, not recognizing who you are, and I'll have a mask on. So you
Awesome.
know. So here's the deal. I'm not done grading the exam yet. I'm frustrated that I'm not that far done that I could return them to you. And do any of you want to know my excuse, or you don't care? Because
Um,
both are fine.
uh,
No, none of you want to know the excuse. Okay.
Let's hear it. Let's hear it. I like a good
Okay.
excuse.
excuse?
It's not a great excuse, but it is my excuse. So, as part of the academic senate in the statewide system, we're asked to review all the pending legislation before the state of California that may have anything to do with the CSU system. And so I had to read 20 about proposed laws. And then because of that, some of the technical details were frustrating or hard to sort of grab onto. But one of them, actually, and maybe Jack, you would have an opinion about this. I don't know why I'm looking at you. You got the mask on. I guess that just jumps right out. There's a proposed law that says the UC should be allowed to have a industrial hemp research facility, but it does not suggest that the CSU should be allowed to have such a facility. And I thought, hello, we're an ag school. I don't know why the UCs should necessarily be given something, free money from the state of California to research industrial hemp when Cal Poly can't. So I had to sort of look into and vote thumbs down on that. So that way the CSU could say, excuse me, legislature, you forgot us. So anyway, that sort of sidetracked me for a little bit. And I honestly don't think I'll be done by tomorrow because tomorrow's the meeting when we discuss all that. But I have the feeling Saturday morning is when I'll have those finished. But that's my feeling. Okay, so none of you. I'm sorry, what, Ted?
The reasoning for them not allowing hemp research at the CSU level.
There is.
What's the reasoning?
I think the reasoning is they forgot that the CSU has the better ag programs. They're right in Davis. Is the Sacramento and Davis, that connection there is so tight that like the Strawberry Center was originally there, and then finally after years of lobbying, Cal Poly said, we should be allowed to have a Strawberry Research Center instead and get state funding, and eventually moved here because we do a better job than Davis. And the Strawberry folks eventually said, yeah, we want applied research, not theoretical, like calculating the surface area of a strawberry depending on the number of seeds or whatever they do in Davis. Okay, so moving towards where we're at, I want to sort of share a screen with you and then sort of let you know about where we're at in the discussion of the material. And then we're going to get to the lab in class today. And interactions, chapter 7, there's at least 2 full class sessions of content on interactions, including one lab today and possibly a lab for next Tuesday as well. And I could probably even do 3 full class sessions on interactions. So depending on how you feel, we'll see what happens next week. But the exam, not next week, but the Tuesday following, or by the Tuesday following, I should say, take it anytime between Saturday and Monday, or Tuesday of the following week. So we're not talking like 2 days from now, we're talking like 9 through 12 days from now is when you get to take the next exam. It only goes through the material in chapter 7. And if you want to sort of pause and sort of focus on that next Thursday, the content, great. Otherwise, we're going to sort of go into chapter 8, 9, and 10 starting next Thursday, moving forward. And 8, 9, and even 10 are not going to seem different from what we've already been doing. So it will feel real comfortable. Well, 8 and 9 anyway will feel quite comfortable, and chapter 10 is naturally going to tie into something that we'll talk about in class even today, although obscure the chapter 10 sort of thought process until we hit it later. Interactions, essentially they're one simple thing, and let me ask you all variations on the same question. How many of you are Bay Area people? Like, yeah, Jack. Yeah, I knew I was thinking Morgan. So if I was going to have to drive to Santa Rosa from SLO, what route should I take?
The 101.
Yeah. Josh and Jack were both talking, and Josh was quiet, and Jack was masked. So I'm not sure which of you. You take 101?
Yeah, I was going to say 101.
But, Josh, you're from Santa Rosa. If I'm heading from here to Santa Rosa, you're gonna take 101 the whole way?
So I take 101, then you take the 85 over to the 280, which takes you onto the 19th Ave, San Francisco. You take the Golden Gate Bridge northbound. You don't have a toll. If you take the East Bay and you take the Richmond Bridge, you do have a toll. So you want to go through San Francisco going north, but when you come back south, you want to take the San Richmond Bridge so you don't hit toll out.
Okay, so I'll see if I could repeat the key part that I'm going to try and leverage for the sake of the next little bit. Go ahead, Josh. Oh, yeah, a map link for Google. Perfect. So, no, if you're driving here to Santa Rosa, you take 101, and then I, most of the time, take 85 to 280, then, like you said, go up 19th Street through Golden Gate Park, and then somehow you end up on 101 again, right south of the bridge, and then you take the bridge, keep going 101, you get to Santa Rosa, we're all happy. If I'm leaving SLO at 8 p.m., and it's not a Friday or Saturday, I'm taking 101 the whole way. Why? Because I don't have to go out of my freaking way to go up 85 and 280, which 101 the whole way can be a little bit quicker. Now, some of you don't know that. Some of you might even argue with me, but let's turn south. If I was driving to Disneyland from my house, and I'm not suggesting via analogy that Santa Rosa and Disneyland are the same thing, but if I was heading to Disneyland, what route would I take? I'm assuming there's some people who are from Orange County or San Diego or at least LA who could answer the question.
405.
You take 405? Well, 101 to
I take the 405.
101 to 405 to what?
And then you get off
To the 5?
Well, okay, so you could take 101 to the 5 and south all the way, or 101 to 405 to 10 to 110 south to 91 east, You could do that, or you could take 405 all the way down till near Long Beach and then do that, half to 3/4 of a mile north and then head straight east. And then somehow you end up near Disneyland. Are there a lot of routes that you could take? What's the beauty of Waze, the software, which now is owned by Google?
It tells you when there's cops.
Well, okay, so fair enough. Besides that benefit,
Well, it measures everyone's speed, so it gives you real-time traffic analysis.
yeah, so I'm thinking that the effect of which route you take depends on, let's just say, the traffic. The impact on the total time to get to that destination depends on how much traffic there is. And I'm betting that traffic is predictable up to a point based on the time of day. Like I said, if I leave 8 p.m. on Thursday night to head to Santa Rosa, I'm thinking I'm not likely going to hit traffic anywhere along the route. Because by the time I get to the city, it's not going to be a big deal whether I'm taking 280 and 19th Street or going up 101 the whole route. Okay. But if I'm going to hit San Jose at about 4:45 p.m. on a Friday, oh my gosh, a whole host of bad options are right in front of me. And the impact of the route may depend on, again, the time of day and things like traffic. Okay? So, the basic idea behind the interaction is this. If the effect of the explanatory variable depends on a different variable's value, you have an interaction. If the effect of one variable on the response depends on a different variable's value or level, that is an interaction. I would argue, and I'm going to do this in a moment with data, my commute time to Poly from my house door to door depends on the time of day. Because if I leave really early before anyone leaves the Los Osos, there's no hassles. And then maybe there is an impact of the route that I take also, okay? But then if I'm leaving during a traffic-y time, I'm thinking something like 8:30 a.m. to get into slow. The impact of which route I take will depend on the time of day it is. So there is a greater distance on the one route than on the other, okay? And then the effect of that route, the effect of the extra distance depends on not just the speed that I'm traveling that's posted as the speed limit, but also on the time of day that I'm traveling. So here's the data. To oversimplify things, I could take Losas Valley Road and then Foothill. LOVR/Foothill is one opportunity, one route. Highway 1 is the other route that I could take, which for me is actually get over to Highway 1 via South Bay Boulevard, but I'll call it the Highway 1 route. LOVR or Highway 1. I could leave at 6:30, 7:30, or 8:30 in the morning. I'm oversimplifying what my options are, but these are the times that I considered for this one particular summer when I drove in at these different times. And I picked summer because there would be less traffic near campus to have to worry about. I was just worried about the Los Osos traffic only. And so for 24 days, and I did not do these in the exact order shown here. This is not the exact order, but I randomized the order, and you learned earlier this term, you should block on things that matter, maybe Friday effect versus Thursday effect, etc. We should sort of randomize to eliminate those probabilistically. I've got how much time it takes me to get from my getting in the car to when I sort of park in the pack structure. Period. That's it. That's what I'm caring about. Okay? So my thought is the time would impact the commute time. Well, of course. If I explore the data graphically, I'm going to just go ahead and use Graph Builder here. The commute time may depend on the time that I leave. That's sort of quantitative, so that makes a nice graph. But separately, I want to show you maybe I'll go with an overlay for each of the different routes. Okay, I could choose overlay, which will break it down separately for each of the different routes, or I could go with that as a color. It doesn't really matter just yet, but if I were to draw in a trend line of sorts, the overlay would do two separate trends, one for each of the reds and blues. If I have just route displaying the color, it would draw in, say, a trend line 1 overall. I'm saying to myself, glancing, red, blue, blue here, Highway 1 takes longer, so Highway 1 takes longer, more time, than Los Angeles Valley Road does. And if I leave earlier, 6:30 as opposed to 7:30 or 8:30, my commute time is less. So this would suggest the commute time was low-ish if I leave at 6:30 or 7:30 and take Los Angeles Valley Road, but the impact of leaving at 8:30 versus 7:30 is pretty big, sort of a large increase as I drift that 1 unit to the right here. If I take Highway 1, yeah, it's going to take me longer, but it does look as though leaving at 7:30 as opposed to 6:30 has the same impact about as leaving at 8:30 instead of 7:30. Okay, so I'm just glancing at the data. I could probably fit a model to these data. The model that we've already considered is the additive or non-interaction model, where I'd say the commute time might depend on the route that I take and then the time that I leave. Route and time both could impact the commute time. It's age, all sorts of standard graphs to look at, and in this case, ignore, because I want to focus in on the key parts. I'm able to explain 92% of the variability with just a model, and that model is describing the different routes, okay, 2.33 extra minutes from taking Los Angeles Valley Road. If I use the expanded estimates, I could also quickly say, oh, negative 2.33, or if you will, 2 minutes and 20 seconds savings of time by taking Foothill and Los Angeles Valley Road. So the swing between the two situations is 4 minutes and 40 seconds. I either take the one route or the other. I can't actually take, well, there is nothing that's called the average route. It's one or the other that I get to choose. Okay, leaving at 6:30, 7:30, 8:30. If I leave at 6:30, I save in 1 minute and 45 seconds. If I leave at 7:30, I save 30 seconds. If I leave at 8:30, I spend 2 minutes and 15 seconds longer driving. Okay, so I'm happy. Okay, if I were to display what those results look like, I guess I could save the trend, but I think maybe under effect screening, factor profiling, I'm just going to go with the profiler. So factor profiling profiler is sort of a nice method of trying to describe what's going on. And you're going to spot that this is like what we'll do in class later today with the interaction as well. Whether it's a model with or without an interaction, this profiler figure at the bottom allows me to get a sense for what the impacts are of the route that I take. If I'm taking Highway 1, we're estimating the average time is 25.833 minutes. But if I want a confidence interval for the average time taking Highway 1, and that's average across, well, at 7:30, I should say, I'm 95% sure that it's in the range 25.068, so 25 minutes and 10 seconds, to 26 minutes, 0.6, that's about 35 seconds. So that's No, that's 25 minutes, 6 seconds, 25 minutes, 5 seconds to 26 minutes and 35 seconds. 95% sure that something in that range is what I'm going to be taking. According to this model, if I were leaving at 6:30 as opposed to 7:30, notice that I have a new estimated average, okay, from my estimates. I'm just saying, here's the estimates presented in graphic form, where I can drag and drop and look at 8:30. Here's what I'm going to be facing: 7:30, 6:30. If I'm taking the other route, Losas Valley Road, I'm going to be at 6:30, taking about 20 minutes, just under 20 minutes. If I were going at 7:30, it's going to be a little bit more. So this profiler is a way of doing some what if sort of calculations, with even a margin of error attached for the average commute time according to each of these different situations. But I'm noticing that the effect of leaving at 6:30 or 7:30 or 8:30 doesn't change the slope. The slope of the Highway 1 to Losas Valley Road or Foothill, okay, that slope there is the same at 6:30, 7:30, or 8:30, even though the average changes its height. The slope being the same says, as I go from Highway 1 and Losas Valley Road, it doesn't matter if I leave at 6:30 or 7:30 or 8:30, the impact of taking the shorter, faster route is always estimated to be the same. Now, we just looked at that graph builder and we said, that's not necessarily what we see in the data according to graph builder, and I now resent the fact that I deleted it, but we can recreate. So the time that I leave and, sorry, the route that I take is over here. I'm seeing that that there is a flat trend from 6:30 to 7:30, and steep as I go to 8:30. For the one route. For the other route, it is the same increase no matter the time of day that I leave. The 1 hour delay causes a delay in a certain number of minutes either way. So my model that I fit essentially was I fit two parallel lines through these data. I don't know that I want parallel lines. Okay, I want the flexibility of the time of day to impact the effect of the route. I'm saying I want the possibility of an interaction. So if you want to, in a word equation, describe what's going on, you simply say, I would like to say there is a time of day effect. There's a possible route effect that, each of those could affect the commute time on average. But the time of day route interaction allows the effect of which route you take to depend on the time of day. Or you could even phrase it the other way around. The effect of the time of day that you leave depends on the route that you choose to take. Usually one of these is a little bit cleaner as a way of explaining things than the other, so I usually prefer to say the effect of which route you take depends on the time of day. How do you do that? Well, I'm going to say the software handles it for you as long as you specify your model correctly. And then all you have to do is to use the adjusted sums of squares for the interaction, or sequential squares, but the interaction being last, to see, does the interaction help me above and beyond what I'm able to explain already with my data? So let's go ahead and try that for the first time. Analyze fit model. I had already fit a model, so I'm going to recall that. If I think I want the possibility of an interaction, a variety of ways to get one, but I said I want an interaction between route and the time that I leave, I could highlight these simultaneously upstairs and click cross. That's it. Another way to do that is I could click route and then over here, time that I leave, and click cross. Or I guess I could have clicked time and I leave here and then route upstairs off to the left and click cross. But the cross means fit and interaction. So my word equation, time of day times route, I've got the time of day times route term in my model. If I were now to click run, I've got still the same collection of things as before. The graphs that I don't really care about looking at. But hey, R squared went up to 95%, so that's good. Working from the ANOVA, at least one of the terms matters. Okay, which term is it? Well, I'm going to skip over the parameter estimates for now. The effects test, remember this is adjusted sums of squares. That's absolutely fine for your checking of the interaction. This interaction is statistically noticeable or statistically significant, if you will. If I were to use the sequential sums of squares, I'm going to say the exact same thing. Always check the interaction first. If the interaction is not statistically significant, removing it from the model would probably be what you'd want to do. Okay? But here I see a need to keep it, so I'm going to keep the interaction. So a question comes to mind. What does the interaction mean for us? My suggestion earlier is my earlier analysis with the profiler did not have an interaction. It showed the parallel trend, Highway 1 to Los Angeles Valley Road, is the same at any time of day. There are two ways of showing that in the output that we've got. You got to turn them on though. Under Vector Profiler, yeah. Let's look at the profiler down here. Same friends as before, except for now, if I were to go from Highway 1 to Los Angeles Valley Roads, notice that at 6:30 we're saying there is a bit of a benefit. At 7:30, it's very steep. There's a great benefit of taking the one route over the other. If I condition on what time I leave has to be 7:30, I'm definitely taking the route that saves me time. If it's leaving at 6:30, it's only a little bit more time. And similarly, at 8:30, only a little bit more time to take the shorter route. But at 7:30, definitely want to take that shorter route. The time savings is reflecting in the slope right here. The time savings is huge at 7:30, not as much at 6:30, and a middling amount at 8:30. If I want to show you that in a different way, under factor profiling, you could look at the interaction plots. If you have exclusively categorical factors, the interaction graph is very helpful as a way of trying to assess what's going on. Let's make it big, and this is something that you already looked at in the context of the pig diet example. Usually one of these two graphs, the upper right or the lower left, will explain the pattern of interest. I usually think quantitative along the x-axis makes sense to me, so I'll probably choose to use this upper right graph where I've got one trend for Highway 1, and it says if I leave at 7:30 or 8:30, it's, yeah, a little bit slower. But if I was taking the other route, Los Angeles Valley Road, 6:30 or 7:30, it just doesn't matter which of those two time slots that I could choose to leave. But if I leave at 8:30, there is a definite increase in then the commute time. Okay, so this interaction graph tells me that story. It does tell the same story down in the lower left as well. If you compare the two routes, again, that's the slope is comparing now the two routes. I'm saying green steep, red and blue flat-ish. And I'm just realizing that JMP doesn't really do a great job for colorblind individuals. Isn't there like red-blue color blindness? Is there also red-green color blindness?
I think it's primarily red-green.
Okay, so the red-green. So for those who happen to have red-green color blindness, we apologize. I should have automatically set JMP to use a different set of defaults. But I'm saying the one is steeper than the other. That's for sure. And I'm noticing then for the steeper of the two, it's hard to tell which of the 3 times that it is, but it happens to be 7:30. The software always seems to go with 1 is in red, 1 in blue, and then green is that 3rd time slot entered in. In this case, it happens to be 7:30. So red and blue, about the same slope, green, steeper. In other words, the impact of which route you take is greater for that green or 7:30 a.m. time slot. We can see that also in the parameter estimates. The parameter estimates, or if you will, the expanded estimates, show us the exact same thing, except for you now get all of the estimates, not just the most limited version of them. Let's verify that with the parameter estimates and now expanded. Notice here for the effective Highway 1, we get that as a plus 2.33, Foothill negative 2.3. That was implied from our non-expanded estimates. I could leave it 6:30, in which case I save time, 7:30, a little bit of time, or I could leave it 8:30. I lose time. Again, the sum of these 3 estimates for the time that you leave sum to 0, so we could calculate that third one for free. The interaction, though, there's a collection of interaction effects as well. I could leave it 6:30 and take Highway 1. I could leave it 7:30 and take Highway 1. Those 2 are reported to us. And the claim is that that is sufficient, because you know that the effective Highway 1, the interaction of leaving at 6:30, the effect of leaving at 6:30 on Highway 1 is to decrease the amount of time by 0.58 minutes. If I took Los Osos Valley Road at 6:30, it would be increasing by 0.58 minutes. Okay, so notice the interaction, Highway 1 and time leave 6:30, negative 0.58. It's a positive over here for leaving same time, different route. So the sum to 0 parameterization constraints apply across both routes, interactions with each of the times. So let's verify that one more time. 7:30, we see a negative 0.5, and negative 0.5 is seen here. What about 7:30? I'm sorry, I apologize. 7:30's interaction with Highway 1 is a positive 2/3. So positive 2/3. 7:30's interaction for the other route is a negative 2/3. And then this negative 0.58 and a positive 0.67, if I sum these 2 together, I have positive about 0.08. The negative of that, okay, is going to be that interaction effect, negative 0.08. The negative 0.08 is the 1, 2, 3 of these sum to 0. Oh my gosh, a lot of work. If you were to algebraically do this, you could construct this sort of a graph, or not graph, but this sort of collection of 1, 2, 3, 4, 5, 6 interaction effects from just the 2 provided due to the sum to 0 constraints. Ultimately, I like looking at the pictures. I think the picture clarifies for me what's going on. Okay? Okay, so that's in the context of a categorical interaction with a categorical explanatory variable. We also can talk about, like the lab does, an interaction between a quantitative variable and a categorical variable. So let's walk you down that path. And in the next class session, we'll talk about the interaction between a quantitative variable and another quantitative variable, or even a quantitative variable and itself, if you will, a self-interaction. So we just did that. Okay, so the categorical quantitative interactions. And the example I'm going to want to use is maybe found in our income and life expectancy example. So let's remind you of where we were and what we already know. Again, the type of country it is, the income, how long the people live, in at least estimated to live as of those that were born in 1972. If I were to use Graph Builder, and Graph Builder is a great tool, life expectancy may be related to the income. It appears to be the case. Positive trend. For country type, I see if I were to choose color, yeah, two definite, red low, blue high. Overlay, again, red low, blue high. But if I now click this button that says put on, these two graphs, and choose to smooth it out, way smooth, or I guess I could just select that, but I get these bands, which I don't really care for. So I'm going to go with the smooth out version. Very, very smooth, causes it to be a straight line. Blue and red. Blue is higher, red is lower. We already tackled that. There is a slope overall, but my question is there a slope that's different between the two groups? An interaction would allow me to check to see if there is a difference in the slope between my two groups. So I'm going to go ahead and fit that model, okay, with the interaction. And let's see if the slope is different between our two groups. So in the data, analyze, fit my model. I want to know, does the life expectancy depend on the income? Okay, and the country type. Just like before, I'm going to highlight income, and country type is already highlit. So click cross, income interacted with type. Good to go, just like the lab will walk you through doing. I click run, and I'm going to do this now and show you some picture, but then I'm going to go back and redo this in what I consider a better way. Not that it really is fitting a different trend, but better in that the output is more convenient. By default, here's what you get. 2 lines. That's what we wanted. The 2 lines have apparently different slopes. That's what we wanted. Are the slopes statistically noticeably different? Let's check the p-value for the interaction term. Down under effects tests is where I encourage you to do that. My p-value is 0.5. I do not see a noticeable difference in the slopes between the two groups. No noticeable difference in the slope between my two groups. Here's the interesting wrinkle, though. Although I fit a 2 trendline model, and I'm happy with R squared being larger than it was before, and my ANOVA is good. Notice that it says income minus 2765.18. That's sometimes called centering, okay? Literally the income minus the average income times then the impact. The benefit of the centering is that it still gives you a reasonable way of estimating the effect of the industrialized versus the effect of OPEC. That sum to zero parameterization will still be required, but the centering says relative to the average income, which is 2760 something, right around here, compared to this point, do we adjust the slope at this point? Or do we adjust the slope, well, at the x equals 0 location? Algebraically, that's what would be most common. Algebraically, you just have a slope adjustment period, rather than relative to 2765. If I were to show you with the prediction expression, I do see everything like before. Prediction expression is your friend. You'll find that in the lab today. My intercept, okay, my slope of income. Then there is the effect of it being an industrialized versus OPEC country. It's one or the other. And then if it is in an industrialized country, we adjust the slope upwards by a negative 0.0067 relative to that average income level. Algebraically, that's a bit of a mess. I could do the work algebraically, but I'm going to suggest the following instead. Don't center. Centering is good. We'll probably by default like to even do that later, but for the sake of doing algebra to figure out what the slope is in each of the two groups, don't do the centering. If I were to have started over and recall, I'm going to refit the model, same model as before. Over under model specs or model specification, notice that the center polynomials button is selected with a check. If you don't want the polynomial terms to be centered, and usually I do want the polynomials to be centered, there are some benefits that we'll emphasize later, but right now I'm going to say I don't want them centered because it messes up my ability to do algebra. I'm going to click there. I've just deselected that option. Notice I go look under center polynomials and now it's not selected, so I'm good to go. If I hit run after having uncentered my analysis, I get the exact same lots of things. Same two trend lines drawn in. Same value for r squared, 84%. Same trend line should be the same r squared, so that's no surprise there. My overall model analysis, same terms. But notice that this income interacted with industrialized isn't income minus 27 something. The minus 2700 something is really a pain in the ass. I don't want to deal with that. Similarly, in the prediction expression, I'm not going to want to deal with that. But notice for the effects test, the exact same p-values as before. Let's go ahead and check that. Same everything as what I saw previously. For the income interaction in the parameter estimates, 0.56, 0.56 in the effects test, yes. 0.0001 type, yeah. The interesting thing here is the 20.5587. Now type has a 25.62. It's off by a little bit in my effects test. The centering does impact the main effects tests. It does not impact the interaction test, which is what we care about primarily. The benefit of centering, though, is really in the algebra. So let's look at our friend, the prediction expression. And that's really what we're going to key off of for many parts of the lab. So let me see if I could get a blank for you. I think I had that here earlier. Okay, so that should turn on the blank. And let's move it over so you can see. Okay, so I'm going to key off of algebraically this portion over here and do a little bit of work like we had done last time. And this is not dissimilar to what will happen for you guys during the lab. So let's go with the black. I'm going to cut down or copy over what I've got so far. Y hat, the predicted life expectancy, is 58.4. A lot of rounding I'm doing. Probably you shouldn't do as much rounding as I am choosing to use. Plus 0.00144 times then income. and then plus, well, one of two effects, 10.4, well, 10.5, because it's 10.46 for the industrialized countries. So if it's industrialized or if it's petroleum producing, it's a negative 10.5. But then there is that one additional term. Okay, so here's a slope times income and intercept. The effect on the intercept, this next term is the effect on the slope of each of the country types. So I'm going to write down plus, and our software says income times the following. I'm going to put something times income because I like the times income to be later. So I'm going to have a negative 0.00067 or a positive 0.00067. And if it's industrialized, it's negative 0.00067. And that's all multiplied by income. So I've got everything copied down. So let's consider each of the two situations, and let's go with, I'm going to go with, I think, blue first. And for blue, I'm going to go with industrialized, because if I remember, that's what JMP had chosen to be presenting in blue. For industrialized countries, I'm now saying y hat is equal to 58.4 plus then 0.00144 times then income plus 10.5 plus then a negative 0.00067 times income. Again, I'm just now telling you only the things that matter for the industrialized countries. But I'm noticing I have like terms that I could collect. There are things without income in them, and there are things that are multiplied by income. So let's combine those like terms. I would say y hat here is 58.4 plus 10.5, that's 68.9. There we go, 68.9. I'm assuming I did that right. 58 plus 10, good, and 0.4 plus 0.5. Yeah, excellent. Now I've got a positive 0.00144 and a minus 0.00067. So that's going to end up positive, and that's going to be positive less than 0.00144. So I'm going to round a little bit in my head to do the work, 0.0007. And then I need the other additional term, and I'm thinking it's going to be a 7. Could one of you confirm that looks about right to you, or what, did I miss a digit somewhere? Again, I got a lecture buzz going, and I didn't pre-do the math on this one.
Looks good to me.
Okay, and the reason I like to stop and pause is if I just tell you what the answer is, at least one group later is going to say, how the hell did you get that? And that would be a good point. So I literally added these 2 terms together, and I got 0.00077 times then income. So that's for just the industrialized group. So I'm going to sort of copy that down here for the industrialized. And I similarly could do this all over again, but for the OPEC group. So maybe let's go ahead and do that exercise, because seeing it twice is always good. So I'm going to go with red for OPEC, because that's what we, I believe, had before. So for the oil producing countries, we'd say y hat is 58.4 Now I'm going to just sort of say minus the 10.5, because I know that, I'm sorry, minus 10.5 is there. Let's see if I could do this carefully. Good. Minus 10.5. So I'm even going to have collected them together right quick. Plus then 0.00144. Now I'm going to add the 0.00067 times then income. Okay, so let's see if I can add in my head or subtract in my head. So 4948.9 would be my intercept. I'm pretty good about that one. And then 0.00144 plus 0.00067. I'm guessing 0.0021 something. And I'm betting a 1. Yeah, that's what I think is. But again, I'm looking at Jack and Yu Chen, the two people who've answered this question. How'd I do, Jack?
47.9.
Damn it. What should I write down? 27.9? Wait. 47. Yeah, there we go. But I was concerned about the slope. Did I get the two slope parts added up? Okay. I knew I felt good for a reason. I just felt good for the wrong reason. Oh well. But algebraically, what we're saying is we've got two lines that are not parallel. They have different intercepts and differing slopes. In that same sense, on the lab today, you're going to work with Duncan's data yet again, and you're going to answer the question, hey, are these two groups noticeably different in terms of the slope? And then you'll go through and do the algebraic calculation. I want to sort of mention one more thing before turning you loose on the lab, and that is in the context of these data. And I'm going to work with the analysis to get you through that one weak spot. And it's going to emphasize something you did on Tuesday, or re-emphasize something you did on Tuesday, and then direct you towards one common question that students have from the lab today. So I'm going to go ahead and do my analysis. Well, I've got it done here. My analysis without the interaction is the one I want first. So I got to fit the analysis without the interaction. So that's what you'll be doing first. Well, I'm going to first off use Graph Builder. Let's start from fresh. Life expectancy may depend on the income. And you're sort of saying if we were to fit a trend line, one trend line, but show you for different groups, we're sort of above the trend line if we're blue, below the trend line if we're red. If we were to fit that one trend line here, I would have noticed blue positive residuals, red sort of negative residuals. You would, of course, then fit two separate trend lines. A trend line, if you will, affect which group it is affect. So let's go ahead and do that analysis. Fit y by x, click recall, and then I'm going to, fit model, analyze fit model, recall, and then I'm going to, for the sake of similarity with the lab, I'm going to go ahead and fit it without the interaction. If I were to run that trend model, okay, we would see perhaps, if I were to choose to save the residuals, the errors around the trend line, I could plot those residuals against the x variable, the income itself. Now the residuals are what was unexplained, and assuming a common trend line, the residuals may show different slopes for the different groups. So let's try that with Graph Builder. The residuals, what was unexplained in my earlier analysis, I was attempting to predict income from I was attempting to predict life expectancy from income. Here are the errors. Now that doesn't tell us which group things were from. If I were to show you in red, you'd say, oh, the blues are to the right, the reds are to the left. I'm thinking that's not a problem. The blues being on the right and the reds on the left, not a problem at all, because the industrialized countries did have higher incomes. The OPEC countries had lower incomes on average. My question is, do we see tending to be positive residuals for the blues and negative for the reds? Not anymore. Having the group effect on the one trend line causes the residuals to be zero on average. But still the slope may have been off. If I were to have, instead of the type being a color, but rather an overlay, it's going to say, well, the red residuals, notice the pause for a long time when I said residual. The residuals, what are they? They are what was unexplained by my model. Now it seems as though the residuals have a positive trend in the red group, and the residuals have a negative trend in the blue group. The residuals having a trend says that perhaps I'm able to explain something in the residuals by knowing just which group it is, and then also the income. I'm suggesting an interaction could have or should have been fit originally. Differing slopes in the residual graph for different groups tells me that my original parallel trend line model was not sufficient in explaining what's going on here. I really want different trend lines with different slopes for each of the two differing groups. Actually, I shouldn't say I want the possibility of, and then I'm going to test that and see if I absolutely need it. Okay, so different slopes in the different groups in an analysis such as this, where I guess I have identified the groups as an overlay, residuals, and then the X variable here. If you spot different groups with different slopes, you might just need an interaction. Okay, any questions on any of this? I feel like that was a lot of content. Yu-Chen, what?
But your analysis showed this interaction was not significant, right?
Correct.
Then why did you want to include the interaction in the model?
Okay, so great point. Ultimately, I won't keep the interaction. I was suggesting if I were to have generated this plot earlier, the lack of parallelness is what makes me think an interaction is worth considering. Yeah. So I did okay, so when you teach stuff, sometimes you teach things in a different order than the way you might pursue the analyses as a statistician. So here I showed you how to fit the interaction model first. And then I went back and said, well, what if I hadn't done that? What would have caused me to want to consider it? The same order as you'll tackle that in the lab. Does that clarify it, Yu-Chen?
Yes, but my question was about that when you are calculating the estimation of the two group.
Okay, yeah.
Then you still include the interaction.
If I wanted to know the intercept and the slope for each of these two, I should say here, for each of the two groups that I had fit with different trend lines. If I want to know the intercept and slope for these two groups, this intercept here, and then the slope for the blue and then the red groups, that's the algebraic exercise I would go through if I were to say, do you need the interaction, or are these two trend lines with noticeably differing slopes? I would say I'm not convinced yet that I need two separate trend lines for the two separate groups. Okay, so yes, there's a collection of things where if you present it in one ordering, it matches what the researcher would do. If you present it in a different ordering, it corresponds to what a textbook would choose as the order for describing the different things. Yeah. So, yeah, we spotted that it was not statistically significant, but then I tackled the what if it were, what would I do to calculate the intercept and slope for each of those lines?
Okay, thank you.
Any last questions before the lab? Okay, so I'm going to put you in breakout groups, and you're going to do the normal thing. I'm going to oh, I almost clicked the end meeting. That would have been bad. I'm going to stop recording.